Okay, so we're going to take a look at how to construct a circumscribed circle for a triangle using the perpendicular bisectors. So we can do this with paper and pencil, but it's so much easier in GeoGebra. So make sure you're on the Move tool. We have triangle A, B, C, and our goal is to create perpendicular bisectors for each one of the legs of the triangle. So we scroll down and we look under Construct, and the button is perpendicular bisector. So you click that button and then it tells you to click 2 points. So you're looking for your line segment. So let's start with A to B. Okay, so A to B, there's the perpendicular bisector. It cuts the line in half 100%. So A and B are equal distance from this point. So let's put a point there. So we have that spot. Okay, so that's going to be called point D. Point D is the halfway mark between A and B. We're going to do that same exact thing for the next leg. Let's go from B to C. Okay, B to C. There's the perpendicular bisector. Let's put a point. This is going to be point E. Point E is equal distant from B and C, halfway mark. All right, last but not least, let's do A to C. Click perpendicular bisector. A to C. There's that line, cuts A and C in half. Put a point there. We're going to call that point F. Point F is halfway across AC. All right, now what we've created here is we've created this very interesting little shape. This is very important. This is where all of those perpendicular bisectors intersect. So we need to put a point there. It's extremely important because this is going to be the center of our circle, guys. Okay, now we have all our perpendicular bisectors. Now, to prove that these are perpendicular bisectors, to prove it, what I'd like for you to do is take the measure tool. So see where it says measure distance and length? We're going to go around and we're going to measure each one of these legs from the equal distance, from the middle. Okay, so distance of A to F, and then from F to C, and then from C to E, and then from E to B, from B to D, and from D to A. And you're going to see, I'm going to use the Move tool just so I can kind of you can see that A to F is the same as F to C. So they are congruent. A to D is the same as D to B. They are congruent. And B to E is the same as E to C. They are congruent because these are perpendicular bisectors. Okay, what this means is, this is important because what G is the center of this triangle. It doesn't look like it is, but it is. A and G are the same distance as C and G and B and G. So G is actually like the center of this triangle. We can prove it. Are you ready? We're going to prove it. Okay, so I'm going to just take a line segment and I'm just going to show you. Okay, and I'm going to change, I'm actually just going to keep it this color. I'm going to measure it. Find the measure. Boom, boom. All right, it's 7. Let's do from G to C. Measure. G to C. Oh my gosh, guys, look at 7. All right, let's do one last line segment from G to B. From G to B. Find the distance. G to B. It's 7. Now, the reason why I know they're equal distance is because G is the center of the circle that is created when you connect these dots around and you make a circle. So that's our last step. We're going to take the circle tool. We're going to start at the center and pick one of your points. Any one, it doesn't matter. G, I'm going to go out to A. Look at that, guys. Bam. Each one of these line segments that connects A to G, C to G, and B to G, they're all the radius of this circle that we just created by creating perpendicular bisectors, finding where they meet, and using that as the center of our circle. It's beautiful. It's beautiful, guys. Geometry is absolutely beautiful. So you will have to do this in your learning check. One of the things you will have to do is construct this, take a screenshot or a picture of this, and upload it. Okay?